In this video, I'd like to continue talking about graphically multiplying complex numbers. And in the previous video, we looked at deriving a formula for multiplying two complex numbers when we start by writing each of these complex numbers in their polar forms, where we have the magnitude of the complex number, its distance from the origin, multiplied by essentially its direction, which can be expressed as the cosine of the angle, where this angle is measured relative to the positive real axis, plus I times by the sine of that same angle. And we wrote the polar form for both z1 and z2, and when we multiplied them together, we were able to derive this formula. And the way to interpret this formula is that when multiplying two complex numbers, we multiply their magnitudes and we add their angles. And for this video, I'd like to look at a specific example so that we can see exactly how this works. So let's start by making a little bit of room, and we can paste in a coordinate plane. And let's say that z1 is equal to the imaginary unit, I, and we can say that z2 is 1 plus I. And let's start by just graphing both of these numbers. z2, we go over 1 and then up 1i in the imaginary direction. And z1, I, would just be on this imaginary axis. Now, with both of these numbers, they're written in rectangular form, but if we want, we can calculate their magnitude and their direction, since we know that the magnitude of some complex number z is the square root of its real part squared plus its imaginary part squared, and its angle is the inverse tangent of its imaginary part divided by its real part. Now for z1, the angle, we actually can't use the formula here since we would end up dividing by 0 with its real part being 0, but we can see that its angle here is 90 degrees. And its magnitude, it is 1 unit away from the origin. So its magnitude in this case is equal to 1. And for z2, we can calculate its angle. We would find the inverse tangent of 1 divided by 1, which we would find is 45 degrees. And you can see that it is essentially is a line that splits the imaginary and real axes. And we can write that for z2, the angle is 45 degrees. And if we calculate its magnitude, we would get the square root of 1 squared plus 1 squared, which, if we simplify that, is the square root of 2. Now, based on this formula, if we plug in what we know about the two numbers, we are now multiplying, and let me make just a bit more room. So z1 multiplied by z2, based on the formula, we would get 1 multiplied by the square root of 2, and we would have the cosine of the angles added together, which would be the cosine of 135, and then we would add I times by the sine of 135. And if we simplify this, either using the unit circle or a calculator, we would have the square root of 2 multiplied by the cosine of 135, which would be minus root 2 over 2, plus I times the sine of 135, which is positive root 2 over 2. And distributing this square root of 2, when we multiply root 2 by root 2, we just get back 2. So for this first term, when we distribute, we would get minus 2 over 2, which is negative 1. And when we distribute for the second term, we would get 2 over 2, which is positive 1, meaning we have minus 1 plus I, which we can graph right here. And we can visually confirm that we are, in fact, adding the angles and multiplying the two magnitudes, since we essentially end up with the same magnitude of this green line here, this complex number z2, because the magnitude of z1 is just 1, but its angle, notice we take this 45-degree angle here, and we add it to this 90-degree angle here, and that gives us this blue angle, which if we calculate this would be 135 degrees. Now, this was all based on the formula, but let's also compare it to the usual way of multiplying complex numbers, where we essentially just multiplied their rectangular forms. And for that, let me just make a little bit more room. We will again calculate z1 multiplied by z2, where z1 is just I, and z2 is 1 plus I. And for the usual way of multiplication using the rectangular form, we distribute. I times 1 is just I, and we get I times I, which is I squared. And since I is the square root of minus 1, we know I squared is negative 1. So this becomes I minus 1, or minus 1 plus I, and we can match that up with what we got using the formula. So the formula does make sense, but it gives us a visual way to multiply these two complex numbers. So if we go one step further and say that z3 is really just this product here, it's this complex number right here at minus 1 plus I, and let's multiply it by z2, so that we have z3 multiplied by z2, and we will multiply their magnitudes, and for both of these, the magnitude is the square root of 2. So when we multiply their magnitudes, we just get 2, and we will multiply that by the direction, but the new direction will be the sum of the two angles. And we have a 45-degree angle here and a 135-degree angle here for z3. So when we add those together, we just get 180 degrees. And the cosine of 180 would be -1, and the sine of 180 is 0. So the product of z3 and z2 would simplify to -2, and we can do that in a different color. So let's say this is now z4, and z4 would be right here. But again, we can confirm this by taking what we know as z3, multiplying it by z2, and when we multiply these in rectangular form, we will see that the imaginary parts cancel out, and we just get -2 as our answer. But having this formula here gives us a nice geometric way to interpret multiplying these complex numbers.